Good morning, everyone. The local time is 4 p.m.
Everybody can hear me?
I can hear you.
Did my computer decide to be bad today? Oh, wait. I know what the problem is.
Is it between the keyboard and the chair?
Okay. All right. So about a minute, we can probably get started. We have maybe, oh, I can't advance slides. That's not great. Hello, Yob. I uploaded some chair slides. Can you make the, maybe I can, let's try this again. Okay. All right, they're working again. All right, we have, I think, 5 or 6 presenters, something like that. It would be great if the presenters could first, before we get going too far along, decide whether or not they can actually make their microphone and presentation work. We can, I think I have all the presentations, so we can run the presentations for you, if that's what you'd like to do, but would probably be good for the presenters to kind of one by one go through and at least make sure we can hear you. Okay. Right. Can't hear you, you're not.
This is Paulo.
I can hear you, Paulo. Oh, that's me. Okay.
This is Mike. Yeah?
Yeah, Mike. I can hear Mike.
This is Camilo.
I can hear you, Camilo. I think, Livio, I can't hear you if you're trying to say something. And I haven't heard Yunnan yet either.
This is Livio. Can you hear me?
Yes, I can hear you now, Livio.
Perfect. Thank you.
I think maybe just Thomas and Yunnan we haven't heard from.
Yeah, hello, Thomas here. Can you hear me?
Yes.
Yes. Perfect, thanks.
Hello?
Ah, okay, there's Yunnan. Good.
Okay, I'll try that way.
Okay.
We are complete.
Okay, all right. So let's back up in the slides. Hello, you're in Bangkok. It's or at least Bangkok time. It's the Grow Working Group at IETF 109. If you are in the wrong room, you probably should change, but This one could also be fun. There's a note well, I'm sure on the second day, you've read this before. If you haven't, it's available on the webpage. Don't read it now. The list of resources for our meeting are the following. The slides should all be updated on the meeting materials page. The chat in Medico is really jabber these days. And I think that's it for those. We will need I think Blue Sheets are all virtual now. They do it based on attendance in the room. We're going to need somebody to take some minutes just to take the notes.
I can take some notes.
Okay, so do that. And then the Jabber Scribe, I guess, I think John Scudder said that we could just use the existing chat thing to do that. So that was in the last meeting I was in with him. So we'll just do that. Okay. Right. There's not really any rehash or agenda bashing. If there's things, we have I think a 2-hour slot. So if there's things that we need to talk about after these 6 presenters, after an hour, we can certainly take time to do that. Otherwise, we can all go back to bed or to the rest of your day, depending on where you are in the world. I think first up is Michael. And either, Michael, you can present your slides yourself, or I can present for you, and you can just say click. It's up to you.
Let me go ahead and try to
Okay.
present on my own.
All right. I think you don't want to do the screen. You want to just pick a particular window if you can. Or that.
How about this?
Perfect.
Great, thanks. So, yeah, this has been a pretty non-controversial draft. It is a BCP, and I'll have to say it's been one of the most pleasurable drafts that I've been a part of writing, because it's been, a lot of people have shown interest in contributing to it. It was quickly adopted, and it's relatively straightforward. However, we need to get it right, because the idea is to provide some guidance to the community. A lot of authors on this. I'm not sure if anybody else is on this call, but we just wanted to give an update. For those that are not familiar with this work, we wanted to make you familiar with it and get some of your feedback. So the background is, back in NANOG 79, Doug Midori presented some information on AS path prepending and the problems that have come from it. And participants asked if there was any sort of a BCP in IETF or any other SDO, and the answer was no. And so we decided that it would be a good idea to do so. The IETF should have a position on this, and this working group agreed. And so the problem is that excessive AS path prepending has caused routing issues on the internet. It can cause routing issues on the internet. And so our objective is to provide guidance to the internet community with how best to utilize AS path prepending in order to avoid negatively affecting the internet, to offer alternatives. The challenge here is to decide in this draft if we want to encourage or discourage AS path prepending. If we discourage it, offer some alternatives. People are using it, so we need to be careful not to negatively attack it. So we need to just, we have time, obviously, but we just need to come up with some good recommendations. And I know many of you have some opinions on this. We've received a lot of good feedback on the list, and we appreciate that. We've put you in as contributors. We have several. One of those is people thought generally that we should anonymize the real world examples, and so we've done that. We've used documentation prefixes and ASs. Some thought that we should just say it how it is and just call people out for what they've done, but generally the feeling is that we shouldn't, and so we haven't, although we do point to URLs, including yours, Jeff, and Doug's, and you can easily find some real world examples that we generically refer to. There's a variety of use cases, variety of reasons people use ASPath prepending. Some of those are included here. Maybe we didn't include all of them. Preferring one ISP over another ISP, one ASBR over another ASBR, utilizing one path exclusively and another as a backup, signaling to indicate that one path may have a different amount of capacity than another. And in some cases, ISPs don't accept traffic engineering using communities, and so it's felt that prepending is the only option. And so we've mentioned those in the draft. We mentioned a few problems where using ASPath prepending negatively impacts the internet, including things like an attacker wanting to manipulate traffic to a prefix and list some shady data center to make that same announcement with a shorter, the same prefix with a fabricated shorter ASPath, and that malicious route would be preferred if RPKI wasn't being used. During a routing leak, you know, one country could have routes that are leaked, and it could be just it was a mistake, not maliciously, and those are preferred because in other countries prefixes are being announced with excessively prepended paths, and so the illegitimate route would be preferred over the legitimate route. And it can also cause problems with platforms, memory usage by BGP speakers, particularly where ASPaths are included in NetFlow messages. We do offer some alternatives to ASPath prepend if that's the route that we need to go, and we probably need to, or we do need to make this more robust and maybe offer some other alternatives. Using predefined communities that are mapped to a particular behavior is one alternative where that's allowed and where an ISP provides that support. Announce more specific routes on the preferred path if that's also supported. You can also use origin codes. When ASPaths are equivalent length, you can advertise paths with an origin where you can have one path preferred over another. And this is probably the most important, I'm guessing, part of the draft that we need to further develop. And this is probably where maybe most of the discussion will take place, but in the draft, what we currently say is that network operators should ensure prepending is absolutely necessary because many networks have excessive prepending. We use some of Doug's information that he's done and to state that there's no need to prepend more than 5 ASs. I think in Jeff's paper on APNIC also, I think they would also agree with that. And we include a diagram that shows that 90% of the ASPath lengths are 5 ASNs or fewer in length, and that's why we say that. And some people, you know, do 20, 30 or more ASPath prepends. Of course, don't prepend ASNs that you don't own. Prepending to all, like if you have multiple providers and you're just prepending to all of them, maybe you've done that because you were prepending to one and not to another, but you discontinued one link and you just continued to prepend on the one link that you still have active. It's really serves no purpose that I can see, and so that you should not be prepending to all. And operators should consider limiting the maximum ASPath lengths that are being accepted as well. So that's kind of a quick run through. We, again, thank you for all your comments. It's been good. We, at the very initial stages of this, we need to make sure that we get this right because we think that the IETF should have a clear recommendation to the community. And if we have time for questions, let's take them.
There's certainly some time for questions. Yeah.
stuck myself in the queue, but as there's been no thing, I'll just start anyway. I'm Jeff Houston. I'd actually like to see a bit more practical advice in this. You talk about at some section, you know, if you have to prepend, do so carefully. But, you know, perhaps what you might also note is a best practice is actually what you should do is actually enumerate what your routing policies are intended to achieve before you even go down the prepending path. In other words, the operator really should understand what are you trying to get out of this before you think prepending is a solution. The other thing that you haven't noted, and I must admit in a former life I was guilty of it, is that sometimes the person you're prepending at, or the network, has simply got an unconditional preference for customer routes, and prepending doesn't work. So again, the sage advice is, before you launch into prepending, A, note what you're trying to intend to do, and B, check with your neighbors that they're even going to honor the prepend, because sometimes you're just wasting your time and creating vulnerabilities because, you know, your neighbor might not actually use it as part of its routing preference. So I would add that in your section 5 about best practices. You know, write down what you're trying to achieve and check with your BGP neighbors that they actually do honor prepending anyway. Thanks.
Very good point. Thank you. And
Any
thank you for your your document that we've referenced. It's been very helpful to us. So yeah, if there's no more questions, Chris, then we're just going to continue to develop this, and we'll send it to the list. And please pay particular attention to the recommendations, because we want to make sure that we're all in agreement on those. Thanks.
Okay. I think next will be Thomas. And, oh, all right, great. You want to do your own slides? Awesome. All right, good to see you.
Be able to hear me as well. Can you see my screen? Can you see my screen? Check.
Yes.
Good. Okay, great. So, good. Today I'm Thomas Graf from Swisscom, presenting the BMP Young project on the virtual hackathon IETF 109 for the Grow and NetConf working group. In this hackathon, in regards of BMP, we were focusing on this BMP draft, where we also see later some presentations in this working group, but also in also regarding IPFix and BGP local correlation with IPFix identity 90, and as well we were also testing performance impact of BMP in terms of CPU and memory resources on the route processor. In regards of Yang, we are working on 2 drafts on UDP Notif and Distribute Notif to have a very lightweight way of collecting Yang data from routers. These are the open source software we have been using in the lab. This is the lab topology consisting of an Empress VPN network with various traffic and BGP generators to validate the metrics throughout the lab. So this time new, this is the 4th time in the IETF hackathon, we added some more different type of vendors. So mainly Cisco IL6R, XE, Juniper TuneOS, and also FR routing, an open source routing system. All of them exposing IPFix and BMP. We were focusing also on Yang schema data collections, and we identified some gaps in our lab setup terms of scalability, data ingestion into the time series DB. BMP BGP is relatively spiky, so we needed to adjust the test setup there to accommodate this. This is currently in work in progress. On the data collection side, on PMA-CCT, the decoding of the BMP TLVs, namely on route policy, attribute tracing, and BMP path marking, continued. We have now pretty good coverage there, and also some extensions in regards of correlating BGP load trip and IPFix has been done, and as well on the UDP notif data collection. This is just an example on the time series database regarding BMP route policy attribute tracing. You can see here on screenshots from an MPLS PE router, basically for a given prefix in a verb, through which verb, route policy, and also type of policy this prefix has been propagated through. Here, another example of BGP local read with IPFix correlation, showing basically on a PE router the test flow being successfully correlated with BGP standard communities. Here, another example on the correlation on BMP BGP local read with path marking, showing a particular path in a verb being best and primary. On the Huawei VRP side, the support of path marking and route policy attribute tracing has been extended and adopted to the latest releases, as well as the coverage on UDP notif and distribute notif for the push data collection. We have been performing some performance tests and to measure the CPU memory impact of BMP. This is an example from two data sets where we were ingesting 100,000 and 500,000 routes to see the impact on CPU usage. As expected, since the BGP propagation has impact on the CPU usage increased, but due to the back pressure mechanism of the BGP to BMP implementation within the BGP process, almost or the memory increase is very minimal. On the Wireshark, on the dissector side, the work is currently ongoing to also support the path marking TLV and the UDP notif implementation. So we are looking very forward within the next 1 or 2 weeks to have that one done as well. What we learned in the hackathon, it's the 4th time, so the team's getting really work nicely together. We work mainly to keep connected, working using Slack, and again, the bad part was no beers and cocktails afterwards. I want to thank all the people who were within the group. Alexis and Uli from Wireshark. We had many people joining from INSA University, Siena and Zeng, and also, of course, Huawei, NTT, and some from Swisscom. That's all. Thank you very much.
Want some questions, Thomas? All right. I guess seeing no question. Is Livio around? And do you want to do your own presentation or?
I tried to share my screen.
I don't just see you sending video. I don't see you trying to present. There we go. As a note to other presenters, it works best if your web browser can just share a single application, not the screen, so we don't have the fall through the YouTube dive-in mode going on like we do now.
Sorry.
That's okay. This is,
Right, can you hear me?
yes, and we can see your screen.
Great. Okay, so I'm Livio Stier from ETH Zurich, and I did my master thesis in collaboration with Swisscom. And I would like to build up on some of the aspects that Thomas was mentioning in his previous presentation and show some practical aspects of BMP. So more specifically, we investigated BMP capabilities in a special type of network, in an MPLS VPN layer 3 network. And we built a pipeline, end-to-end pipeline that consists of everything from exporting BMP data, collecting it, processing, storing, and visualizing it. And the goal was to do a correlation on a VPN level where BMP is just a small part, where we also included forwarding plane metrics for IPFix, which then enabled root cause analysis and real-time performance monitoring. So if we quickly look at the BGP protocol, which BMP monitors, then essentially we have two different entities. We have RIPs, so-called routing information bases, which is just a list of prefixes with attached attributes. And an example of this is a BGP update message that can be seen on the right side. And we have so-called route policies, which operate on the routes. So they can modify, drop, permit them, and so on. And if you look at BMP, what BMP enables, and this was an iterative approach. So the first standard was done in 2016 and enabled access to adjacency RIP-in, pre and post policy. It also set up the protocol mechanics in terms of communication, and it was also possible to send certain statistics. And in the next step, it enabled access to adjacency RIP-out. This is also a standard by now. And you can probably also see the trend here. In next step, if you wanted to know what routes are actually installed independent of the BGP peering, we enabled access to the local RIP. And this is also, so if you imagine that a BGP peer receives hundreds of thousands of updates, but only a tiny subset of them actually modify the forwarding state of the router, it's a big efficiency gain if you just monitor the local RIP. But monitoring the local RIP also enables certain correlations that were not possible without it. That's the case in MPLS VPN network. And sometimes there are multiple paths for a prefix. For example, if you have a network that is built with redundancy in mind, and there the goal is to have an additional path marking draft where you can see, okay, this path for this prefix is a primary path, this path for this prefix is a backup path, so we can see the redundancy throughout the network. And as a last step, we enabled access to route policies, where we can see which policies were triggered and which modified routes and how. So this is just a quick evolution of BMP. And what we were most interested in is to apply all of that in a special type of network, in an MPLS BGP IP virtual private network, which is a common architecture for ISPs because it enables multiple VPNs to be run over the same physical infrastructure. We have a couple entities here. So we have the CE routers, which is just a route from the customer's premise, provider edge, which is on the provider's premise, which borders to the customer edge router. And then we have an MPLS core and the routers in there, which is denoted as P routers. And what we have is that if multiple VPNs want to share the same prefix, which should be possible, then we need a way to sort of distinguish them. So then a new concept, which is called virtual routing and forwarding instances, is used to isolate the routing tables of the different VPNs. And there's a route distinguisher attached to a VRF. And basically, this creates also a new address family, the VPN v4, v6, which is essentially just a concatenation of a route distinguisher with the IP address. And with that, we can actually make the same prefixes from multiple VPNs unique. And this is also important for the correlation later on, if you want to do a correlation on the VPN level. And as has been shown by Thomas in his previous presentation, this is the lab network that we tried to experiment with BMP. We have a couple of P routers in the middle row. Then we have multiple vendors, Cisco, Huawei, Juniper, and we even used F4 routing as C routers. We have a route reflector, and we have Spirent for traffic generation. Now, what we wanted to do here is that we first wanted to export the data. So we had to specify which RIPs and which address families. That's obviously vendor specific. Then we used the collection software PMACCT, which we are previous as well. And there the route distinguisher that we just mentioned before was used to correlate IPFix and BMP messages. So in the end, our goal is to sort of make queries for a specific VPN. And the correlation enabled us to enrich the forwarding plane with control plane attributes, such as the AS path or standard community attributes, which encode VPN information. And one of the supported backends of PMACCT is Kafka. So we use that as our message broker, which is able to buffer the data. We split the BMP output of PMACCT into its individual message types to make it a bit more scalable, and then we ingested it into a time series database through it, which is optimized for event data. And as a last step, we use the Node.js application to handle requests between the front end and the database. And the front end is an interactive UI which can filter the data and shows the resulting graph. And to linger a bit longer on that point, so the visualization supports, on the one hand, exploratory for a given time range, but also real-time queries for different BMP message types. We want to achieve a correlation in this type of network that I showed on a VPN level and in time across the two planes to make cause and effect visible. So on the bottom is a screenshot of the application where we see on the left side the control plane with different filters for standard communities, which, as I said, encode VPN information, RIP selection, and also timestamps. And if you just want to look at an example query, let's say we have a query where we say, for a specific VPN, show me a certain RIP, for example, that chases the RIP in pre-policy and its correlation to the forwarding plane. And the events that we're interested in is just enabling, removing and enabling an interface on a VPN level. So on the left-hand side, we have removing of the interface. So as soon as we take the interface down, we have BGP updates propagating through the network, which are then exported with BMP. We can see here on the left-hand side is the control plane graph, where the nodes or the vertices are just the loopback addresses of the routers, and the edges are the next hops. And we use prefix here as an aggregated form because there are multiple prefixes that can have the same next hop. And the edges are color coded, and red means that we just saw a withdraw message. And the interesting thing is that, for one, this is on a VPN level, and on the other hand, we just correlate in time. We have this vertical bar that shows where in the forwarding plane this event actually happened. And because we disabled an interface that was generating traffic, we can see that the traffic broke down at the same time. And after a couple of minutes, we re-enabled it again. And here the color is green. That means we have a BGP update message that was captured with BMP. And then the traffic pattern went back to normal. And so this is just a toy example, but it just shows that what kind of information that we can get out of it. So if you're interested in this kind of event, we can dig a little deeper. For example, we can see, okay, let me change the RIP. On the left-hand side, now we have the chased RIP out for exactly this event, for enabling the interface. And here again, the nodes are the loopback addresses of the routers. The edges are the next hops. And we have additional fields that when we click on the edges, that we can see the prefixes that had this specific PRIP and BGP next hop tuple. And on the right-hand side, we have the route policies that were mentioned in the previous presentations as well. And this is essentially a bipartite graph with the BMP routers that exported the BMP data in one set and the route policies in another set. And the edge label is the peering over which that route policy is triggered. And let's say if you're interested in more information, then we can just click on a certain vertex, for example, this one up here. And then we have an additional additional information, for example, what policy class this route policy corresponded to, whether the route policy was matched, whether the route was permitted, and so on. We even included an additional text field where we actually use an RPC call with netconf_yum, where we called or queried the router directly for its route policy. And as maybe to conclude, this is just a toy example. We can see that with just a very simple example, we can get a whole lot of information out, which can be used for all kinds of use cases. Okay, thank you very much.
Anybody have any questions? Like, where could I download the software and what is required to run it on my machine, on my network? That sort of question. No. All right, thank you very much, Livia. That was pretty cool. Paulo, do you want to run your own presentation too?
Yes, let me try that. Technology is one of my weak points, so let me...
All right, we can hear you, and shortly your screen should share. Hopefully not fall into the mode.
Yes, I'm trying to do that. I'm trying to do that. 1 second. It could be this one. No, it's not.
All right.
I'm trying to fix this. 1 second. Enter screen. It is so confusing when you want to just select one screen.
Okay, I think somehow the Linux version of all this got the whole thing correct, where they give you a different tabs and you can press the tab for the applications and select the particular one.
Right. And otherwise I will share the whole screen. 1 second. Yeah, I can't find what I'm looking for. So okay. All right. Can you see my screen?
Fall into the mode accomplished. Great. Okay, now we can see just the presentation.
Fantastic. I cannot see I can see only my presentation. So, okay. So very quickly, 2 updates on the TLV draft and on the TLV EBIT draft. So I start from the TLV one. We, problem statement of the TLV, just as a super quick recap, like extend support for TLVs to all BMP messages, so cover specifically route monitoring and peer down. And in order to achieve that, we bump the version for backwards compatibility. And so what happens since IETF 106, since we didn't present at 107 and 108, it's that we had 2 new versions, the -3 and -4. So just for historical. So what happened mainly is that we posed ourselves the problem of per NLRI TLVs. So the fact that in route monitoring messages you have a BGP update message, and in the BGP update message you can have multiple NLRI, and then maybe you want to correlate a specific TLV to a specific NLRI. So of course we didn't want to be just positional, like basing on some sort of ordering of the TLVs, because that can be very easily screwed up. So just for a little bit of history, something that we never presented and we already deemed as a distraction of a few months. Our first attempt went to go for let me call them TLV containers to achieve that. TLV containers would be like that you have a TLV, for example, let's say for path marking, and then inside that TLV you have sub TLVs, right? And the sub TLVs would be just ordered, specifically the way in which you want to, the first TLV would be matching the first, NLRI and things like that. This method, we deleted it from history because let's say it was bringing, some disadvantages. It was a little bit complex. Also, you have the problem when you don't want to attach a TLV to a specific NLRI, like you have, I don't know, 3, 4, 5 NLRIs, and you want to attach a TLV only to the first and to the third and to the fourth. So it was becoming a little bit kludgy. You can have null TLVs, but it was bad. So we restored a little bit of simplicity in the whole thing. And so in version 4, which was published just yesterday, we have indexed what we call indexed TLVs. So essentially, it's just a super normal TLV. It's just that the very first value, the first 2 bytes of the value, it's the index. So the index starts at 0. So the index 0 would be for the first TLV, and so forth. Super cool. For the moment, we are leaving to the let's say it's to the specific application. So index TLV would be like a recommendation, let's say, like how to encode, per NLRI TLVs, and it's left to the specific. For the moment, it's left to the specific application, the knowledge that, there will be an index. So the TLV, it's indexed or it's per NLRI. In other words, we are not adding a flag or anything like that to say that the specific NLRI it's indexed, right? We may think about that. We are open to feedback on that one specific item. It would be nice to have, consistent TLVs, and I specifically come from the IPFix, experience where, you have this TLV kind of protocol where everything auto parses very nicely. So be able to have, a flag for something would be nice. But, we are open for feedback and on that. Other changes, we added the operational considerations section, which is largely based on Jeff has feedback. Thanks very much, Jeff, for your feedback. And there were minor editorial changes. I present also this, and maybe then we can do questions at the end if there is any. So on the EBIT side of the things, what is the problem statement? I will actually kind of skip the EBIT problem statement because there was quite a large recap on the mailing list on what this is about. So you see here, the problem statement mentioned in the draft, but we went also through, some other possible. It emerged on the mailing list a few other possible use cases for this draft, right? And so, what is the status and next steps? And this is my last slide. So there is not really many open questions since there was not much feedback to this draft. A couple of weeks ago, I sent an email with a little bit of a recap and asking a little bit for support, not support, and things like that. I think we received some, positive feedback. So definitely positive feedback, no negative feedback. And the actual feedback is going to be processed. There was quite some suggestions from Thomas Graf. Thank you, Thomas, for that. And, question for the chairs, like, shall we go for adoption for this draft? And as always, I hope we have an exit 0. Any questions?
I think for the adoption thing, please email the list.
Sure.
Yeah. No other people with questions, I suppose.
Cool.
We'll move on to Yunnan.
Thank you.
Thanks, Paulo.
Thank you.
Hello.
Hi, Yunnan, do you want to present or do you want me to do that?
I'd prefer to share my screen.
Okay.
I really want to share your screen. Yes. So, application linked. There we go. Okay. So you're looking at my slides, right?
Yes, can hear you, see you, and see your slides.
Okay, so I'm gonna start. So I'm Yunnan from Huawei, and it's actually been a year since I presented this draft at IETF 106. Well, actually, we've been working on the the revision and also the implementation of this draft for almost 2 years. And so today I want to discuss with you the latest status of this draft, and also would like to discuss with the working group how we can take this draft one step further. So first, I'll quickly recap you with the hackathon example that we have for this feature, and then we're going to look at the latest status of the format, and then we'll discuss the next steps. Okay. So in a nutshell, what this draft does is that it basically records the root policy processing in the device, and then encapsulate the root policy processing data with BMP, and also export the data using a new BMP message. So in this figure, you can see in the left column, there are different data fields. These are the raw data fields that you catch from the BMP root trace message. And then in the right part, what you can do is basically you drag different data fields to either the filtering column or the show column. Okay, so for example, in this example, we want to show you in the last 5 minutes what this 0.71 router is doing under a certain VRF indicated by this RD. And then in the show column, basically you can select different fields to structurize the data to the way that you want to visualize the data. So here we showed 3 data fields. The first is the VRF name, and then the policy class, and also the policy name. So for this router, under the VRF C20, basically we can see here we have 4 types of policies: the inbound policy, the VRF export, and the route withdrawal and outbound policy. And we can also see that under each policy class, under a specific root policy name, how many events is going on. Okay, and for those names with a NAR, it basically means the policy either the policy is not configured under a specific root policy, or the root is processed by some default configurations. So next, we want to zoom into these two events. So what we can see from the raw data parsed is that it's actually two prefixes, .10 and .252, which are received from the same BGP peer, and they are processed by the inbound policy, and the policy is a match, and the match result is to permit the policy. And then this policy's diff field tells you whether the BGP attributes before the policy and after the policy is different. So if it's 1, then it basically means it's different. So to look at the detailed difference, you want to go to the pre-policy attributes and the post-policy attribute. But here we didn't actually fully parse the two fields, but once you do, you can see the difference. Okay, so that finished the quick recap, and this is the latest format that we have for the root trace. In fact, from the 03 and 04 version, we didn't make very big changes to the format, just minor ones. And also, I don't want to talk about the details of the formats. Instead, I want to discuss something else with you. So I'll just go ahead and skip. And this is the changes from the last version. Okay. And a big thing that I want to discuss with the working group today is that how can we move this work forward? And before that, I want to update you with the current implementation status of the draft, and also some deployment status and future plans. Okay. So we have now Huawei VRP latest version that supports the latest draft as a BMP client, and we have PMA-CCT that supports the latest version draft as the BMP server, and we also have Wireshark that supports parsing. Okay, and for deployment, we have been testing this feature in the Swisscom test lab for almost for over a year, and for actual deployment in the production network, what the information I have here is that first, there could be plans in the Tencent network. Actually, this draft is also a requirement from the Tencent, and who is also one of the co-author. And the second is the new IXP in China. Luckily, I was involved in this IXP project since this, I think, this year, May. And I've been introduced this feature to them. They are pretty interested, but for the exact deployment plan, I currently don't have. And also for Huawei Cloud, they also have plans to deploy this feature. Okay, so with these things going on, what I want to ask from the working group and also the chairs is that shall we consider the adoption of this draft as a working group document, and also we would like early allocations for the following code points because we are going to deploy the feature in actual networks. At least that's a plan. But I do understand there are still concerns and maybe even big concerns from the working group, and I would really like to discuss these concerns.
Go ahead, Jeff.
Hi, Jeff Haas. Wasn't it the case at some point we talked about changing the registration policy for the BMP message types? I think the real issue here is that we don't have any first come, first serve, and this is a good candidate for that.
Mm-hmm.
I thought that John, maybe he's here and remembers, I thought we pushed through a change that turned it to a first come, first serve. John Scudder, I mean.
I am here. I don't remember. That sounds right. I mean, somebody could go look at the registry right now. But
Yeah, I'm checking now. I was looking at the RFC, sorry. It is currently still half the code points are standards action, the other half are specification required.
So it has to be a working group document for early application. Am I right?
So not speaking for the chairs of this group, my memory of specification required is that a internet draft is present, and it doesn't even necessarily have to be an internet draft. You could actually do standards in another organization and just simply say, this is where it's specified at. So there are options to be done, but it still requires chair action.
specification required is weird. I don't remember the details, but I think it may not work the way you said. But standards action certainly can, you can get an early allocation, and I don't think standards action technically requires you to be a working group draft, which is kind of weird. It's chair's discretion, I think.
As chairs, we'll take a to-do item up to see where the registry reclassification project is, because I suspect it got lost somewhere in the 2020 dumpster fire. So in summary, to you, you want to get working group adoption call going and explore IANA early allocations. And with both action items, we will help you.
All right, thanks. Thanks a lot.
And Warren might have a question, I think.
So specification required, I'll put the actual text in the chat, but basically the designated expert has to say it seems mostly sane, and then you need a permanent and readily available specification. It needs to be sort of relatively stable. It's unclear that an internet draft is that if it's expected that the format and protocol will still be changing.
Okay, thank you.
Thank you.
And provided no other questions, we can skip on to Camille.
Thank you.
Thank you, Yunnan.
Hello.
Hello. Do you want to present your screen or
Try.
present your application? We'll try that.
I cannot share. Well, I also cannot share specific apps, so I'm sharing my host.
I think I pushed the wrong button. Sorry. You'll have to click again.
I have to click again? Okay.
Yeah. I clicked on the kick you out of screen share button instead of add you to screen share button.
Yeah. I can only show grow. Can only show the tabs, so there the screen should be. I don't want to waste more time. Okay. Yeah. Seems like I cannot share the screen for some reason.
Okay. Well, one more try while it tries
Yeah,
again.
try again. I'll try it again. Share the screen. No, it says error. The object cannot be found. Whatever.
Okay. No big deal. Let me find.
Yeah, will you help me with the slides, please?
Yes, one moment while I rearrange my screen
Okay.
that it works.
Perfect.
Okay.
So I should start that. So this is an update on the BMP pad status TLB draft. The next one, please. So as a brief recap, the idea of this draft is that is to convey pad status over BMP. So pad status being whether a path is installed, whether a path is not that, so whether a path is best path, whether it's not a best path, but we're still using it for forwarding, so we call that primary, whether it's a backup path, so this kind of thing. Livy mentioned it also on his talk, so is that kind of, so the data could be useful, I guess, for some use cases. It depends on the BMP TLB draft and on the EBIT draft too, that Paolo just mentioned. So we also have a reason field, which now is optional. The reason field could include stuff like, hey, this path is best path because, I don't know, has higher local preference, stuff like that. So it might be a bit complicated for every use case, but it could be useful for troubleshooting. Yeah, we decided to set it as optional now, since it might not be useful every time. Could you do the next one, please? Okay, as overview of the latest changes, so we didn't show it for a while. We actually have been iterating over it. It's very related to what Paolo mentioned about the index. So we have this issue in which, and Paolo just described it, that we could not, so it was complicated to point out what the TLB to which NLRI was specifying to, it was referring to. So we did some hacking, so not some hack, we play with positions a bit, but it was too complicated, so we went into this index thing. So basically, it's a field, numeric field, in which you define there to which prefix on the BGP update the specific TLB you're referring to. No, seems to be fine so far. So we also implemented the EBIT that basically allows you to, so if you have your own company status or your own reasons, then that are not standardized, then you can use that one. And then, you can do any status you wish until those status are properly standardized, hopefully. And we also set the reason code now to be optional, so I guess it doesn't waste time if you're not implementing it. And those are basically the main changes that we have. The next one, please. In the implementation side, so we were doing these hackathons every IETF. Well, I'm not so much involved, but the draft has been there for a while. But we realized that waiting for every IETF to, let's say, have an iteration on the draft between the router and the collector was taking too long, and we had very good discussions about it. So we wanted to have something quickly. So let's say quicker iterations about the messages and about the format and all of that. So we ended up, let's say, implementing BMP in this framework, a Python framework called Scapy, which is basically a framework that allows you to force packets. So we have kind of a prototype for BMP now. It works, so it includes the TLB options, and particularly the path status option. We made that work with the PMHCT collector. And that allows us to, let's say, have a quicker iterations. So if we had a new version of the messages, then we can just implement it there in a couple of days and make it work against the collector. And just doing that, doing it practical, allows us to more quickly have discussions and stuff like that. So it has been useful. Thomas and Libby also showed that we have been testing this now, let's say, more end-to-end between router and let's say, information systems on the hackathon project. I'm not going to mention any more about that, but it's good try to work it out practically and in an end-to-end environment. The next one, please. So as the rest of the drafts, I think we have enough interactions on this draft. The data is there, but status can be useful for some use cases. We don't have a way of conveying that information, so that's basically the gist of the draft. Obviously, it depends on the other ones, so on the TLB and the EBIT and the others. So we probably in the next weeks, if nobody says anything, we'll try to go for working group doc or whatever the chairs suggest. Yeah, and that's it. So if anybody has any questions, then please. I see Jeffrey is there. So.
Thanks, Jeff. Quick comment on the index hack. I think it's a nice hack. I think major challenge there is that it's sort of assuming that the receiver is capable of parsing out the NLRI, which for cases where you're using route monitoring is mostly used for things that are been accepted by the stack and are able to be validated. For route mirroring or something else similar, you probably can't get around to doing that. So you probably do need to restrict it to only being used for route monitoring, and you may want to have further discussion about, as part of the TLV work, do you want to split the NLRI out into separate fields that are a little bit easier to parse? Because one of the headaches BGP has had over the years is if you can't figure out where the NLRI boundaries are, the rest of your parsing gets strange anyway. And now you're actually building other fields based on success of being able to do that.
Right. In that regard, I have to say that I have discussed with the GrowTLB authors, well, basically, that this kind of infrastructure should lay more in the TLB draft. So that should be mandated by that, let's say, general architectural draft than on the specific, let's say, content TLBs, because if every content TLB does anything differently, then that will become kind of a mixture. But yeah, I mean, all of these comments are very useful, and let's see.
Any other questions? And I think we finished up. Thank you, Camille.
Mm-hmm.
Right. I don't think there's anything else there's nothing else on the agenda. If there are other topics that need to be discussed, I'll give you a minute to figure that out. Speak up.
I think there's a to-do item for Warren related to the charter of Crow.
Yeah, we sent along. Go ahead, Warren.
Hi, thanks for reminding me. I believe that the action item is I need to chat with Alvaro, who's got some comments or questions on sort of making sure that we're not overstepping our bounds. And I think there are also some comments from Randy on some definitions on things like securing BGP and things like that. But yep, you're right. Sorry.
Okay. Seeing nothing else, I suppose see you in 4 months. If there's something we need to talk about in the meantime, always please ask the list if we can set up an interim meeting. It's very easy to do for us. We just need 2 weeks or so notice. See you in 4 months.
Thank you all.
Thanks. Bye.